everyone, welcome back to A+ Maths. These questions can be done in many different ways, and one way is not right or wrong or better or worse than another method. I might do these questions differently than your teacher at school, and that's fine, and you need to make a decision on which method is best for you. If you're getting the method right that your teachers taught you at school, then continue to do that method. You don't need to do it my way. We can now move on to non-monic trinomials. Non-monic trinomials means that it has a number in front of the x squared. Let's have a look at my method. I won't go into too much detail on how the method works, but it's a method that always works. We know that these are non-monic trinomials because it has a 2x squared, and over here it has a 3x squared. So the number in front of the x squared is what tells me that it's a non-monic trinomial. As soon as I realise that it's a non-monic trinomial, I know that I need to start like this. 2x, 2x, all over 2. Better not to ask too many questions as to why. I can go into it and explain it to people who want to, but I would imagine that if you're watching this video, you just want to know how to do the questions, and hopefully again later in time, you'll be able to understand why the method works. And then over here, because it's got a 3x squared, I would do 3x, 3x, all over 3. We just copy whatever's numbers in front of the x squared. The next step is tricky. Well, it's not. The next step is a little bit unusual. I need to say 2 times 6 is 12. You always multiply the first and the last number together. 2 times 6 is 12, plus 12. I'm now looking for a number that multiplies to give 12 and adds to give 7, just like I did before with my normal trinomials. 4 and 3 are looking good over here. 4 times 3 is 12, plus 4 plus 3 is 7, and plus 4 times plus 3 is plus 12, just checking it as usual. You could look at that and think that you've finished, but of course you haven't finished because you have a fraction all over everything that can be cancelled. You should always be able to cancel the fraction in a non-monic trinomial. So you need to factorise one or both of the brackets on top, on the numerator, and then it should cancel with the number on the bottom. So if we have a look at our two brackets on the top, one of those brackets will always be able to factorise. So I can see here 2x plus 4, that 2 goes into the 2 and the 4, so I'm going to factorise out a 2. Just like we did with our easier factorisings. I can check 2 times x is 2x and 2 times 2 is 4. I can then cancel my 2's and I write down what's left. And that will be my factorised answer. Let's have a look at the next one. We've already started it. We knew that there was a 3x squared. And because of that 3, it made it a non-monic trinomial. And that meant I needed to just start by saying 3x all over 3. Easy part. The bit that you need to remember to do is 3 times 4 is 12. Minus 12. 3 times minus 4 is minus 12. We now are looking for a number that multiplies to give 12 and adds to give 11. 12 ones. Good on you. 12 and 1, we write the 12 and 1. It doesn't matter where I put the 12 and where I put the 1. I usually just do it in whatever I thought of first. Now I need to get plus 11. Plus 12 minus 1 gives me plus 11. And of course I'm going to check that plus 12 times minus 1 gives me minus 12, which it does, so I know I'm right. My next step, always, will be to factorise one of the brackets or both of the brackets on the top, so that I can cancel with the number on the bottom. I can factorise a 3 out of this first bracket. 3 times x is 3x. 3 times 4 is 12. All over 3. They cancel because that was the whole point of doing it. And I'm left with x plus 4, 3x minus 1. I hope you're following so far what I've done. I know that this can be a little bit overwhelming and it's very different. So let's do 2 more examples just to solidify what we've gone over. 3x squared minus 17x plus 10. Definitely a non-monic trinomial because there's a number in front of the x squared. How do I start? 3x, 3x, all over 3. I need to remember to times the 3 and the 10 together, and I get plus 30. And now I'm looking for numbers that multiply to give 30 and add to give 17. It's a bit tricky, this one, but I'll tell you that there's 15 and 2. Hopefully you're going, oh yeah, I would never have thought of that. And to get minus 17, I do minus 15 minus 2. I need to factorise one of the brackets on the top, or both of them. In this case, there's only a common factor in there. There's no common factor in the second one. So I'll just factorise this. And I get 3 times x is 3x. 3 times 5 is 15. All over 3. Of course, the 3's cancel. And then I write down my answer, which is x minus 5, 3x minus 2. And the last question I'm going to go through before we do a more difficult one is 5y squared minus 2y minus 3. Always start by writing 5y, all over 5. That's our standard start. And don't forget to do your 5 times 3 is 15. If you forget to do your 5 times minus 3, then you will not get the answer. Multiplying to give minus 15 or 15, adding to give 2. 5 and 3. 5 times 3 is 15, minus 5 plus 3 gives me minus 2, and then I factorise out from the first bracket. The 5's cancel, and we're left with, hopefully, everybody got the same as me. Alright, a slightly more difficult question. It doesn't look different to the others. Actually, you wouldn't think this was difficult at all. And it's not really a difficult question. There's just an extra step that you need to be aware of that pops up every now and again. And I think it's good to have seen it before it pops up. We're going to start the question just like we always do by doing 9x, all over 9. What's our next step? To multiply the 9 and the 4. 9 times 4 is plus 36. What multiplies to give 36 and adds to give 12? 6 sixes, good job. 6 sixes, and minus 6 is minus 12, and just checking it, minus 6 times minus 6 is plus 36. So we know we're on the right track. Now we have a slight problem here, because we need to now factorise to get rid of the 9 on the bottom. But when we look at this, you can't take out a 9 from the first bracket, and you can't take out a 9 from the second bracket. Now I did mention that sometimes you need to take out the common factor from both brackets. That's how this question is different. I can take out a 3 from the first bracket, and I can take out a 3 from the second bracket. So let's see how that works. If I take out a 3, I'm left with 3x minus 2. And if I take out a 3 from here, I'm left with 3x minus 2, all over 9. Now I can cancel, but 3 times 3 is 9. So everything cancels, and I write down the answer. So in actual fact, the only thing that was different in this question from the ones that we had done before was that I needed to factorise both of the brackets, and then the denominator cancelled. I hope you get it. Thanks for watching again. Don't forget to subscribe below so that you get notifications when my new videos come out.